Good evening, everyone. Welcome to this PCB design workshop. I warmly welcome you to the session. Thanks for coming and thank you for your time. And today is day 9, so we have 3 more days to go. Today topic is we are going to review the schematics as well as the footprints linking. Okay, so this is what we are going to do. Yesterday, we have covered up the schematics part. Okay, so we have not reviewed the schematics. We have not verified the schematics yesterday. So we are going to review the schematics today, and we are going to create footprints and we are going to link the footprints. Okay, so first I would like to welcome you, the early comers. Sai Teja, good evening. Kyle Willy, good evening. Sean, good evening. Viranjan, hello. Viranjan, hello, good evening. Rahil Varora, good evening. I'll go through it, Rahul. Shandarsh, good evening. Krishnan, good evening. Uday Lakshmi, please email the software link. It's there in the Telegram group. Uday Lakshmi, it's there in the Rohit, good evening. Sai Sudhir, good evening. Shraddha, good evening. Raj Kumar, good evening. Sai Kiran, good evening. Rashmin Kumar, good evening. Shalini, good evening. Nishant, good evening. Basavaraj, good evening. Sunita, good evening. Rahil, I will go through it and I will get back to you within today or tomorrow. Okay. Sunita, good evening. Adishri, good evening. Sean, good evening. Jalal, good evening. Oh, good evening. Okay. So thanks for coming and thank you for your time. So let's start before we go to the topic, I'll give a short introduction about Pantech and about me, and then we can go for the session. Okay. So about Pantech. Pantech was started in the year 2004. Like we basically manufacture embedded motherboards. Like we manufacture motherboards like microcontroller boards, DSP boards, and FPGA boards. Like we do also manufacture a lot of sensors and the electrical and electronics trainer kits for engineering colleges. So if you want to know more about our products and services, just log on to our website pantechsolutions.in. Okay, our vision is to help 10 million students to learn the technology in an easy way. So far, we have covered up 1 lakh plus students on YouTube, and this year we have a mark of around to train 8 lakh plus students. So we have a lot of upcoming programs. Like we have programs on MATLAB. This month we have programs on 30 days programs on MATLAB, and we also have programs on machine learning 30 days and the embedded C programming. Okay, embedded C programming on 30 days. So these are the upcoming programs. So stay connected on our channel, so that you will get an update. And about me, my name is MK Jeevarajan. My primary expertise is on microcontrollers. Like I have worked on various microcontrollers, DSPs, and FPGAs. Like I have also worked on various image processing and deep learning algorithms on both MATLAB as well as on OpenCV. So this session is about sharing my knowledge with you. So if you want to connect with me, you could connect with me on the LinkedIn. So I have provided the LinkedIn in the description box. So I'm happy to connect and happy to help. Okay. So coming to the announcement, the link will be available at 9 p.m. So the minimum attendance required for an e-certificate is 12 days. I will be waiving off 1 or 2 days. So 10 days is enough. And if you submit a project, the schematics or Gerber, then definitely even below that also it's okay for me. You have to complete the task. Okay. So the attendance link will be valid for 1 hour after the event. So you could fill the attendance form even after that event. It will be in the chat box. Okay, for internship candidates, no need of attendance. It will be accessed from the LMS portal. So the portal is on we are working on the portal. Like the videos will be most probably it will be updated within this Sunday. Okay, all the videos for 12 days will be updated within this Sunday. And if you have not joined on the Telegram group, you please join on the Telegram group for the materials. Okay, so on the last day I will be sharing those materials again, from day 1 to day 11. So you could download the material presentations, and you could download the schematic PDF file and other footprints. I am also going to share the footprints today, so that you could design your own 8051 board. Okay, so I have already shared the schematics. I'm not going to share the DSN file. Okay, DSN file I'm not going to share. The schematics file I have shared as a PDF file. You have to draw your own schematics, whereas the footprints I'll share you the footprints. Okay, so no need to create the footprints for all those things. It will take more time. If you do the job, like, then it will be more familiar for you to come. But you have this footprints as a reference one, and you could use this footprints, and you could completely do the layout. Okay, and completely you could complete your own 8051 board. Okay, so that's the main objective of this program, to design your own 8051 board, 8051 microcontroller board. And the certificate of internship is available at 300 rupees. Like, you will get the recorded video access. There is also a combo offer, like PCB design plus embedded system design plus IoT plus FPGA, 999 rupees. Okay, plus Arduino is also 999 rupees. So it has 6 months validity on the portal. Let's go for the mindset lesson today. Okay, so today mindset lesson is like uh, from George Bernard Shaw, like the people who get on this world, like all get on this word, or the people who get up and look for the circumstance. Okay, so like, if you can't find them, like, you could make them. Okay, so don't wait for the circumstances. Look for the circumstances you want. If you can't find them, you just make them. Okay, so the first and foremost rules for success is never complain. Okay, it's never complain on your team, or never complain on your friends, or never complain on the family. You should never complain. Okay, if you want to be more successful, like, you should have the habit of never complaining others. Okay, and believe and succeed. So these are the things which I would like to share you today. Let's go for the session. So before that, Tejashri, good evening. Rahul, good evening. Sonali, good evening. Krishnamaraju, good evening. Narasimhan, good evening. Jalal, good evening. Singla, good evening. Gayatri, good evening. Sanjay, good evening. Rahil, good evening. Okay, so so this is a board which we are designing. Like, I will explain you again. Like, I will just give you a small recap. This is a 8051 microcontroller board, and this board, like, we are going to use, like, the power supply design. We have completed the schematics, the complete schematics. We are going to verify the schematics today. So the power supply design, we have the power supply design, and we have the FT232 serial port. Okay, for USB programming. For USB programming, you could also program this IC through normal serial port, RS232 serial port. Either way is possible. If the laptop does not have the serial port, then you could use this USB. So USB UART, it acts as a like USB to UART driver. Like, so FT232, like, it acts as a driver. So whatever the serial communication, it converts to USB and give it to the PC. On the PC part, you should have a special software, like the hyperterminal software for viewing this one. Or you could, like, it will also once you connect this board to the laptop, like, it will give you a COM port. Okay, communication port on the device manager. So you could use a communication port on the programming software to program this IC. Okay, so, and this is a reset switch. Okay, reset switch, and this part is the crystal circuits. And this I will disable my okay. So this is the interrupts. This two switches for interrupt study. Okay, and this we have 4-pin headers. So this is to connect the FRC cable to other boards, or we have terminated the IO ports, like port 1, port 3, and port 2, and port 0. Okay, so the port 0, you have to use a SIP resistor. And again, like, we have a 20-pin box cutter here, like, this is also for external connection. Okay, so if you want, like, you could remove this one, because this is enough. This 10-pin header 4 is enough. If you want, like, while you are designing the board, like, you could remove this one, so that the complexity of the layout, like, you could reduce the complexity of the layout. Okay, let's go for the schematics. Okay, let's go for the schematics. I'm opening the schematics. Rohit, like, the acrylic sheet is just for, like, it's just for packaging. Like, it's not for start circuit, like, just to finish the product. Okay, to have a look and feel. and it also gives some protection. Okay, so file open design. Okay, I'll open the design from like I have it on day 9. Okay, so this is a schematics. This is a schematics which we have drawn yesterday. Okay, so let me check. Okay, so like this this spot, like we have the reset pot here, the crystal pot here. Let us verify the reset pot. The reset pot is here. Okay, these green colored dots are like for error. Okay, so I have just before this event, like I just run the drc and check, we have not linked the footprints, so it's showing error. Error, I will tell you how to remove this error. Okay, so if you check this reset, okay, if you check this reset, like we have vcc 5 volt. Okay, vcc 5 volt switch, 10 microfarad 63 volt, 8.2k, 8.2k. So this is okay. Okay, this is okay. And xl1 and xl2. Okay, for crystal, so it's 11.092 megahertz, 33 picofarad, x1 and x2. Okay, 19 and 20, 19 and 18. It is connected to pin 19 and 18. Okay, 33 picofarad. We got this. So this is okay. This is okay. So and then like everything has been terminated for the nets. Okay, terminated for the nets. VCC and ground is 0.1 microfarad. So VCC 0.1 microfarad, ground, it's okay. So the rest of the thing is okay. So here, like we forgot to put this SIP resistor. SIP resistor is not there for port 0 because it's open drain. Okay, so we need to put a SIP resistor here. So it is, the SIP resistor is 8. Okay, so I take the SIP resistors. Let me find some place, like I just drag and drop this one. Okay, so it should be port 0 here. It should be port 0. So I just copy this. I just drag and drop. Okay, should be no, it should be. Okay, I'm just connecting the SIP resistor. It's 10K. Okay, so I have just connected the SIP resistor for 10K. Okay, so like this part is completed. This we have verified this 8051 part. Now like max 232. Let's verify this max 232 part. So first we will verify this VCC and V plus. Okay, VCC and V plus is 10 microfarad. Okay, 10 microfarad, T1 in and T2 in. Okay, T2 in is should be connected to TXD. R2 out should be connected to RXD. R2 out. Okay, C1 plus and C1 minus 10 microfarad. Okay, and C2 plus and C2 minus it's 10 microfarad. And ground we have 6 is 10 microfarad and D9 connector. Okay, it should be connected to 3. T2 out should be connected to the third pin. T2 out is connected to the third pin, and R2 in should be connected to the second pin. R2 in. Okay, R2 in should be connected to the second. R2 in should be connected to the second pin. Okay, so max 232 is verified. Max 232 is verified. And like we will verify this EA and PSUN. Okay, EA and PSUN is pull up is 8.2K. EA and it's EA and PSUN, like we have to connect through a resistor. It's here like EA and PSUN. Okay, 8.2K. And the interrupts is also like interrupts. It is connected to 3.2 and 3.3. Okay, it is connected to 3.2 and 3.3. And P3 underscore 0 and 3 underscore 1, like it should be connected to RxD and TXD. Okay, so the next spot is FT232. This one, FT232. So FT232, like we have FT232 here. Okay, FT232, like one VCC is 1. We have made a slight modification here, like there is no ferrite beads here in our board. Like there is no ferrite beads. I have removed that one. If you want, you could make it one, but it will work. Okay, but the recommended thing is you have to put a ferrite bead here. So I just removed this one. Ferrite bead, it's connected to USB. So USB power. D minus should be 16. D plus should be 15. Okay, D minus should be connected to 16, and D plus has been connected to 15. And VCC, like VCC have to connect to the header here. VCC, it is connected. VCC has to connect to the header. Okay, so it's a jumper. It's a jumper. And VCC IO, VCC, it is also connected to VCC IO, and it is connected to a decoupling capacitor, 0.1 microfarad. Okay, this ferrite bead is also connected to a 0.1 microfarad. Ferrite bead is also connected to a microfarad, and this ground is connected. Okay, Okay, so this is 6 and 5. Okay, 6 and 5 is, so the rest of the part 7, 18, 21, 26, and 25. 7, 18. Okay, we have forgot to put this ground here. So 7, you have to connect 7. Okay, we have to connect ground. Okay, so 7, 18, 21, 26, and 25. So 7, 18, 21, 26, and 25 is ground. Okay, and 1 and 5 is RxD and TXD. Okay, 1 and 5 is RxD and TXD. So this is connected to the microcontroller. Okay, TXD and RxD. So if you could disconnect this IC by using this header. If you want to disconnect FT232, if you remove this jumper, like there will not be power supplied to this FT232. So this IC will be disconnected. Okay, TXD and RxD. So the rest is like ends 24, 28, and everything has to be 24, 24 RTS, CTS. RTS, CTS is connected to a header here, but we don't want that. Like we are going to terminate this one. Okay, RTS, CTS, and DTR. It is just to use as a test points. If you want, you could use this signals, but mostly we won't be using this RTS, CTS, and DTR. Okay, so I just terminated this one, RTS, CTS, and DTR. And NC reset, NC reset, where is reset? Okay, reset is also terminated. Okay, reset 24 and 8. 24 and 8 is 24th pin, and 24th pin is terminated. Okay, and 8th pin is also terminated. Oscillator out and 3v3 out is also oscillator out and 3v3 out. 3v3 out and oscillator out. The pin number is 28. Okay, 28 is terminated. Okay, oscillator input is also terminated. Oscillator input is terminated. So FT232 is verified. Okay, FT232 is verified. And let's go for these are the mounting holes. Okay, these are the mounting holes. Let's keep 4 mounting holes. Like create new part. Okay, okay, just a circle. You could switch off this grid. You could move it. Okay, and you could enable this one. Okay, Save this one. Right click and close. Okay. So I will have four for mounting screws. Okay. Okay. So let's verify the power supply part. So we have verified this power supply. Power supply, everything is completed. Only the power supply part is there. Okay. So the DC jack. Okay. DC jack. Bridge rectifier, like bridge rectifier meant 1 2 3 4. Okay. It's 1 2 3 4 and 7805. Okay. 470 microfarad, 25 volts, 100 microfarad, 63 volts, 0.1 microfarad. I just press R to rotate. Okay. Okay. So LED like 3.2. So this VCC and USB. Okay. So this is a slide switch to switch over, like whether you could use this wall mounted power supply or from the USB connector. So this switch is used to switch on, like whether to use the adapter or whether to use the USB power supply. Okay. So let's so we verified all the schematics. Let me give me a minute. I will post the attendance. Give me a minute. I have posted the attendance on the. I have pinned the attendance form. Okay. I'll also give you the group. Okay. So, so we have verified the schematics. Is that clear? Is that clear till this point? Is that clear till this point? So we have completed the schematics now. We have completed the schematics and we have also verified the schematics. Is that clear? If you have any doubt, like you could put your questions on the chat box. Is that clear? Is that clear? Like we have completed the schematics and we have also verified the schematics. Okay. Just type clear in the chat box if it is clear. Just type clear in the chat box. If you have any questions, put it in the chat box. Like I will. Rahul Ramesh, thank you. Sean, thank you. Only two clear is there. Is that clear? Thank you, Saiteja. Thank you, Vedant. Sagar, thank you. So let's move for the next one. Okay, so like we have so far we have completed the schematics and we have also verified the schematics. Okay, let's go for the uh, okay, let's go for the so I just go for the project folder. Okay, I just go for the project folder. Like I go for this annotate, I click annotate, I click reset part references. Okay, I click reset part references, click OK, and then click incremental reference update. Okay, incremental reference update. I click design rules check. Yes, click yes. View output, electrical rules. Okay, report all net names, report off grid objects. Okay, and click OK. Click OK. So if you check this, like it will show off error. Okay, it will show all those error. Like if you check, like you have USB, see globals, we have USB 5 volt and ground. Okay, ground is 0. There is no name for ground. Okay, the name is ground. So I just change this name. Okay, but some part is 0, so we have to copy and paste everything. Okay, so we have to change all those things. Like I'm just changing the ground. Save this one, read in the program. Give me a minute. Like actually, I'm modifying this ground. Give me a minute. So I rerun the DRC check again. Okay. So this zero we have to remove this zero actually. Like there are two net names. Okay. Okay. Let's find out in the last like I just go for this page. Okay. So I have a details of the counters here. Like in the Excel sheet, like I have the details of the footprints. Okay. So for zero point 0.1 microfarad, so I have a folder called footprints. I'll show you this footprints. I click copy. Okay. File open. So I'll share you this folder. Okay. So capacitor through hole. Okay. Capacitor through hole like DRA. Okay. So this is the capacitor for the through hole capacitor, like for the 0.1 microfarad. Okay. 0.1 microfarad. Like for the SSOP package, okay. So this is the SSOP package FT232. Okay, this is the package for FT232. So like this, I have already taken the names of this one, names of this like names of the footprints. Okay, so for LED 3mm. Let us check for LED 3mm. Okay, I'll share you this footprint folder. So this is LED 3mm. Okay, footprint for LED. For 89S to S52, like with the zip socket. Okay, so this is the footprint for the zip socket. Okay, for this one, this for this zip socket. Okay, you could also have a 40 pin IC connector for dip IC connector. You should also have. If you put this zip socket, like you could remove this IC so that you could also use this as a programmer. Okay, so you could also use this as a programmer. Okay, and file open like so resistor footprint, like resistors footprint. Okay, so this is the footprint for resistors, for through hole resistors. We are going to use through hole resistors. You could also, if you want, you could also use SMD. So for resistor for connectors. Okay, this is a 20 pin box header. And this is for 10 pin box header. Okay, file open. Okay, for 10 pin box header. Okay, so so we have to copy this one, like capacitor, like we have to copy this one. Just go for 10 microfarad. Okay, copy this part, and we have to give this on the footprint. I click edit properties. Okay, choose all the 10 microfarad. Okay, right click edit properties. Okay, so in the footprint value, you just give the footprint. Okay, save this file. Okay, so you could cross verify with BOM, like 10 microfarad. It is total quantity is 5. So it should have 5. We have only 4. Okay, so 10 microfarad 63 volt is here. It is also here. C2, C3, C4, C7, C8. Okay, C2, C3, C2, C2, C2 is here. Like C8, we have C8. Okay, choose this one. Okay, 10 microfarad. Am I audible? Am I audible? If I am audible, please type yes in the chat box. Am I audible? Okay. Okay. Thank you. Thank you. Thank you so much. Thank you, Pratik. Thank you, Sean. Thank you, Neha. Okay. So we have to give footprints. We have to link the footprints for each and every components. So I'm just copying this. I just copy this footprints. I just modify this for 33 picofarad. Okay. Let's complete one by one. So I just copy this 33 picofarad. Okay. On the footprint tab, like you have to modify these footprints. Okay. $470 microfarad. So I'm just modifying this footprint value, PCB footprint name. Okay. So you have to give the footprint name for each and every components. Okay. So save this program. save this file. Sorry, save this file. So copy this. You just modify the footprint. Edit properties. Okay. Modify the footprint value. Have to give the name for that one. Okay, I'm just giving the footprint name. Okay. So I'm just giving the footprint name. I'm choosing all resistors. Okay. So we are giving the footprint names. Like I'll share you this Excel file also. Okay. So let me check the DRC check now. Like I run this DRC check. So these are the errors still. So if you check on the page, max 232 does not have a footprint. Zero 0.1 microfarad. So I'm just linking this footprint. Okay. Om Patil, like you could access on learn.pantechsolutions.net. Learn.pantechsolutions.net. Om Patil, like you have to access on learn.pantechsolutions.net. Okay. So we have to give this footprint for each and every IC. Like let me check. This switch does not have a footprint. Okay. So switch this slide switch. Save this one. So 0.1 microfarad, like 0.1 microfarad is still there, like 0.1 microfarad. Okay. Let me check the DRC again. So we have uh, 5 errors. FT232, FT. Okay, this is okay. This is okay. Ground is okay. Footprint, PCB footprint on C2, C12 and J1. Okay, save this one. I run the DRC check again, design rules check again. Click OK. C2. Okay. Okay. So we have like there is no footprint error. Okay. So ground mismatch is there. Like check power ground mismatch. Okay, it has duplicate pin. Okay, this is duplicate pin name and see. So this is not a problem. Okay. So this is not a problem. Duplicate pin is not a problem. Okay. This is also not a problem. So we have to this zero, like we have to check. It should not be there. Right, net names zero, we have to check. Okay. So the footprint error has been like we have removed the footprint error. So let's continue tomorrow. Like we could generate the netlist tomorrow, and we could import this to the board file. Okay, we could import this to PCB layout, and then we could layout this board. Okay, with this, let's close the session today. So far, like today, like we have verified the schematics, and we have also linked the footprints for each and every components. I'll share you this. I'll share you this Excel file, like the details of this footprints, as well as I will also share you the footprint folder. Okay, the footprint folder, like which where you have this DRA file, so that you could open this file and you could check. You could check all those footprints. Okay, so the USB footprints. Okay, USB footprints, and every footprint is there. So you could check this file. You could create the schematics, make once you create the schematics, then link all those footprints to the schematic file and generate the netlist. Once you generate the netlist, then it could be imported on the PCB editor, and we could place the components, and we could route the board. Okay, so I'll take the questions. Om Patil, thank you so much. Shiva Karpolik. Uh, Shiva Karpolik. Mounting holes and turrets. Like mounting holes and turrets are almost same. Okay. The purpose is same. Like mounting holes is to mount the boards, like to give the screw or like that. And turrets, it's like to hold the component, to hold the board like this. Okay. Please help me out. I need some guidance. Shiva Carholic, like you just follow this channel. You follow this channel, you will get a lot of course there. Okay. So let's thank you so much for your time. Thank you so much. Let's meet tomorrow, and like tomorrow, like we'll be generating the netlist. Okay, we'll be generating the netlist, and we'll be uploading the like we'll be routing the board. Sudhir, like I think some of one of the ground is mismatched. Like I will check this and I will let you know tomorrow. Okay. Sai Sudhir, like I will let you know tomorrow. Difference between RS230 and FT232. Devyan Shingla. See, RS2 FT232 is for USB. Okay, because your PC, your port, your laptop does not have the serial port connector. So you could use FT232 will act as a driver which converts the RS232 signals to USB. Whereas RS232 just a serial communication, like where it could connect with other microcontrollers or other PC. The length you could communicate 3 meters of length, 3 to 10 meters. If you go for RS485, like you could go for 10 meters, whereas RS232 will come up to 3 meters. Rahil, definitely I will check and I will give you the solution today, possibly today or tomorrow. Within tomorrow 10 o'clock, you will be getting the email from me, Rahil Varora. Pratik, thank you, Pratik. Krishna Manu Raju, like I have the link, I have provided the link, like I will also share you the link here, like the combo offer. Okay, the combo offer for so I will share you the link for embedded system design and FPG and PCB. Okay, both for Arduino also is there. I will also share that one. Abhishek, we will be the PPT is there on the whatever the PPT, the materials, it is there on the Telegram group. At the end of the session, I will share you all those things again. Okay, so those who join lately to the Telegram group, you could collect all the PPTs on day 11. On day 11, okay. Definitely, Romulo, I will update the portal. Definitely, please give me time till this Sunday. I will update all the thing on the for the PCBs. Okay. Assignment link, I will give you to on day 11. Day 11, I will give you a Google form where you could submit the assignments for schematics. If you submit the schematics, see, even though if there is less attendance, like I will consider and I will release this certificates, free certificates. Okay. Those who are submitting the assignments, either schematics or the Jabber file. Okay. So definitely, even though if you have less attendance, you will get a certificate. So thank you so much. Thank you, Gayatri. Thank you, Hari Chandru. Thank you, Ramulu. Thank you, Abhishek, Rahil, Devan Singh. Thank you, Ondan. Thank you. So thank you so much. See you on the next session tomorrow. Until then, bye bye. Welcome.